Bismillahirrahmanirrahim. In this video, I will continue talking about two-part K full factorial design of experiment. In the previous video, I talked about two full factorial design of experiment, and we consider example of this one that was in a response variable. We have the defect per unit, and we have two factors. One is time, another is pressure, and both the factors has two level as we are discussing 2 part K. And we were repeating the experiment 3 times. In this particular video, our focus will be on 2 part 3. That means we have 3 factors. One is feed rate, that is the experimental factor. And as second factor, we have the depth rate. The third factor, we have tool angle. And we are interested in checking the surface finish of our product. And as we are discussing 2 part K, so that means every factor has only 2 levels. So one is low, another is high. So whatever we have decided, the feed rate low level, what you are decided, and whatever the high level you have decided. So based on that, I have taken the example that if all 3 have set low level, the surface finish is 9. Similarly, if we set the feed rate high, okay, and depth rate low and the tool angle low, then the surface finish would be 10. Remember that right now we have considered that in this particular example, or as well as which we have discussed earlier, as well as in this particular example, we are considering the factors level as a text. That means either the value would be the low, either whatever the rate you have decided, either the value is high, whatever. Like for example, just example, I am saying that the tool angle is 2 or whatever, or the higher value is 3, right? So whatever, either I'm giving a numeric number, but that number would be considered as a text, right? So we want to analyze this one, and we want to repeat this experiment 2 times, right? So first, what we want to do, we will design a design of experiment. In order to do that, we will go to Stat, DOE, then Factorial, create Factorial design. Again, type of design, we will select 2 level Factorial. And how many number of factors we have? We have 3 factors. So if we click on design, they are asking whether you want to half fractional factorial or full. So right now we are talking about full factorial. We are not talking about the fractional factorial design of experiment. So previous video we talk about full factorial, in this video also. So when we are selecting the full factorials, you can see that 2 part 3, that means total 8 experiment in one replication we have to conduct it. Okay, but the replication is as the data suggests, we have to repeat 2 times. So that's why we are asking that the number of replication must be 2. So press OK, and then we will click on factors. So they are saying what is a factor A? That is basically we have a feed rate, right? The first one is a feed rate. The second one we have depth rate. Second one, the B factor is a depth rate, and the C, the third one is the tool angle. So that is a tool angle. And again, I am, as I told you, that I am considering it their levels as a text. So this is low, this one high. So -1 means low and +1 means high. But I am exactly writing down those names, low and high. This one is high. So this one is low and this one is high. Okay, so press OK. So option again, what I am trying to do, I don't want that the experimental design shouldn't be random, but it's a good practice to make it as a random. But because I have already got the results, so that's why I don't want it should be on a random form. So press OK, and then this is the table I want to see, and press OK. Okay, so in in the upper part, in a session window, we can see that the number of factors, and in one experiment, how much number of experiment we have to perform A, because we are repeating 2 times, so 16. Okay, and this is a table. So all sets are low, then the first is positive, then negative, right? Okay, so this was the table. So we have basically designed that 2 part 3 design of experiment. So we need to perform 16 experiments. As I've already performed, so the output is, that is surface finish. So with respect to every factor level, we have computed the value. So I have written down. So when we have feed rate low, depth rate low, tool angle low, we found that the product surface finish value is 9 and so on, right? Now, after uh, completing the design as well as performing the experiment, now we want to analyze it. So for analyzing, we will go to Stat, DOE, then Factorial, and again we are going to click on Analyze Factorial Design. So the response is surface finish terms. Okay, so this is very important. So how many terms you want to incorporate? Like right now we have 3 factors, so that means 3 terms, and then there are interaction with 2 factors like A, B factor means feed rate and depth rate interaction, AC means feed rate and tool angle interaction, and so on. Similarly, we have ABC, that means feed rate, depth rate, and tool angle interaction. So now you need to tell whether we want to 2 factors or all 3 factors, right? So right now we are taking as all 3. So press OK, and then what we need in a graph, yes, we want Pareto chart as well as normality, as well as this 4-in-1 mean, that is after fitting the ANOVA model, that is a 2-way ANOVA. Right now we have 3 factors of Factorial ANOVA. So we want to check the residual properties of the ANOVA. So then press OK. This one is a simple, you can use extended one, it's up to you. Press OK and again OK. Okay, so in order to interpret it, so we have regarding the interpretation perspective, we have the coded coefficient. That coded coefficient means when we are talking about the feed rate, so it's coded coefficient, either it's low or a high, right? So whatever. So right now we are talking about perspective of this particular factor, and we can see the corresponding p-value. If the p-value is less than 0.05, we are considering the alpha value 0.05. That means I am 95% confident about my decision. So that is also indicating that there is a 5% error in my decision. So that is pre-decided, which is alpha. So my feed rate is a significant factor. That means feed rate is significantly affecting the surface finish while we are shifting from low to high. Depth rate, it might be possible right now as I have considered all the interactions. So right now it is look like because it is greater than 0.05, so that is not significant, but we will check. It might be possible if I delete from the model of all 3 factors interaction, or maybe 2 factors interaction, that might be possible it becomes significant. We will check later. But right now, if we are interpreting this one, because the p-value is greater than your pre-decided alpha value, which is 0.05, so that means we will say except h0, that means depth rate as well as tool angle are not significant factor, as they are greater than the p-value and they are not significantly affecting the surface finish. Similarly, the two-way interaction mean feed rate, depth rate, feed rate, tool angle, depth rate, tool angle are also not significant factors, as they are greater than your pre-decided alpha value. Similarly, all 3 factors interaction are not significant. So the only significant factor is the feed rate. Okay, and the second thing is we can also see the VIF, that is called as variance inflation factor, and the variance inflation factor, if it is 1, that means we are in a good shape. That means there is no multicolority exists between the independent variables. So what are the independent variables? That is feed rate, depth rate, as well as tool angle. And what is the dependent variable? That was a surface finish, right? And then the next important thing over here is that is basically the value of the effect, that is indicating when a feed rate is shifting from low to high, how much surface finish affects. Okay, so right now it is indicating that if we are shifting the feed rate from low to high, the surface finish will be increased 3.375 unit of the feed rate, right? So using these effects, we can calculate the coefficient of the regression line, which is y is equal to a plus bx plus b2 x2 and so on, b1 x1 and so on. But as we have seen that according to this result, these are not the significant factor. Only the significant factor is feed rate. So our regression line would be, our dependent variable is surface finish, would be equal to the constant value, which is 11.063 plus we have the coefficient of the feed rate 1.688 feed rate. So this would be our regression line in order to predict future surface finish. If we set the feed rate, whatever the value is, we can predict what would be the surface finish. So there is no need to incorporate all these factors, as these factors are not significant. This thing we will discuss again later. Okay. So I hope you clear this table. Now we are going to discuss the next table, that is called as a model summary. So this model summary is indicating what? That is the R square, which is indicating 79, or adjusted R square, which is 60.66. So this is indicating, if I am interpreting the adjusted R square, that is all the independent factors that we have taken, that is feed rate, depth rate, tool angle. All these three factors are able to define the variation in the surface finish up to approximately 61%. The remaining approximately 39% variation are unexplained, or you can say we don't know what factors can explain those variation in the surface finish, right? So right now, this model is able to explain the variation in the surface finish, that is due to the feed rate, depth rate, and tool angle up to approximately 61%. Okay. So one more thing, that as the R square is higher, that better the results is, right? Okay, the same thing is analysis of variance is telling us more specifically, first of all, is this model is significant? So we can see that model's p-value is 0.029. So that model is significant, means that is a good model. It's fine. We can say that we can rely on the result of this model, which is actually surface finish. Surface finish is equal to the constant coefficient, which we have discussed above. Let me show you again. That is this one, which is 11.063 plus 1.688 feed rate. That is our model, right? So that model is good, right? So feed rate is a significant factor. We can see this one from over here. Let me show you this one. This feed rate is a significant factor. These are the same p-value which I have already shown you above. So this would be the exactly same answers, right? So only the feed rate is a significant factor, and now we can see the regression line which the MiniTab is providing us, but there is no need to consider in the regression line of all these factors, because they are not significant. These factors we can remove from the regression line. So the only regression line we can use to predict the surface finish, that is on using the feed rate, right? So that would be the more better regression line, because that is a significant factor. Okay, so furthermore, normal probability plot is also indicating that, as you can see from this graph, is the maroon color or dot, or you can say square dot, is indicating that the factor is significant. The blue dot is indicating that these factors are not significant. Similarly, we can see from the Pareto chart, only a factor, which is a feed rate, that is a significant factor. Okay, the rest of that are not significant factor. But again, as we can see that from the Pareto chart, as well as we have seen from this, you can say coded coefficient, as well as from ANOVA, that it might be possible that the depth rate can be a significant factor, or it can be, if might be possible, if I remove all three factors interaction, then it might be possible that this particular factor might become a significant or factor, or might be possible other factor could be the significant factor. How we can do that, we will check later. But right now, we can see that only factor A is a significant factor, as well as the residual properties are fulfilled. It looks like the residuals are normally distributed, and there is no a specific trend. This is look like a constant. It's look fine. So let's again do analyze again. Right now, what I will do, I will remove this three factor interaction. So how you can do that? You will go to again start DOE, Factorial, analyze Factorial design, and in terms is we will remove this three factor interaction using this way, and only two factor interaction, and all three factor must be there. So press OK and again press OK. Now we can see that again only the feed rate is a significant factor, and after removing the three factors interaction, no other factor become a significant factor. We got the p-value is higher than the previous one. So let's do the same. If I should remove from the terms BC factor as well as AC factor, let's say only as well as AB. So what's the effect? What I got this one. Again, we can see that only the feed rate is a significant, depth rate as well as tool angle is not a significant factor, right? So depending upon your situation, you can check that. So you have to check iteratively whether after removing or after adding this particular factor, what's the effect is occurring on other factors. So right now, again, I am using all three factors. So let me analyze again. So all three factors, so press OK and again press OK. So we have already interpreted it. Now I am going to do the that is factorial plot. You already know it. If I click on factorial plot, so that is only using the model term, yes. So main effect as well as interaction effect. Again, as I told you in the previous video, so the main effect is indicating what? If this particular line is you can say as this particular line has more and more slope, that is indicating the significant factors. If this line is horizontal, then this is indicating that this factor is not a significant factor, which means if I am moving my feed rate from, you can say, from let me show you, from low to high, is there a significant factors occurring on the average surface finish or not? So as you can see that from graphical perspective, we can see that it might be possible that all three factors are the significant factor, but you can see that this has more slope compared to these one. So they are might be possible, they are not significant factor, which we have already seen from the ANOVA table as well as coded coefficient, that these two factors are not significant factors. So similarly, in order to check the interaction plot, we can also see that if the lines are cutting each other, then we can say that, or you can say crossing each other, then we can see that those two factor interaction as the significant factor on the surface finish. So from this graph, we can say that it might be possible that the feed rate and the depth rate as well as depth rate as tool angle have the significant factor, significantly affecting their interaction. But we have seen from the ANOVA result that the interactions are not significantly affecting each other. So these are just the descriptive, or you can say the graphical representation of interaction as well as the main effect. And it's a good practice to report them, but you have to rely on the results of the ANOVA or the coded coefficients table. Furthermore, we can optimize it. How we can optimize it? You can use click on response optimizer, right? And what's your goal? So what do you want to do with the surface finish? Let's say I want to say that I want to hit the target, okay? And my target is, let's say that is 5. Just example, I am considering it just as an example that my surface finish must be 5. Okay, so then we can do the setup. Okay, so this is the weightage they have given us, and then in the end we have graph, and remaining all things are okay. So just press okay. Okay, so they are saying if you want to hit your target, that is 5, okay, that you are not able to get it with this current setting, whatever you are using, because if you, the optimum answer right now you are getting is, that is basically 8, okay, but your target was 5, and the 8, you cannot reduce your value from 8 to downward, because if you change your setting from low to high, this one, so you can see that your y is increasing instead of decreasing. So this is the best optimum answer. And how you are getting this one? If you set the feed rate low, depth rate low, and tool angle high, low. So if all three are low, then you would able to get the surface finish 8. That is the optimum answer. So if you want to reduce it, then try different levels, right? Okay, and similarly you can predict that one. The prediction is indicating that your surface finish become 8 if you have the setting of all three factors at a low level, and I am 95% confident that your surface finish will lie between 3.59 to 12.41, right? If you are start setting your feed rate at these low and high which you have decided earlier. I hope you understand about the 2-part 3 full factorial design of experiment, how to design it and how to analyze it. Thank you so much. See you in the next video.